Hi, this is Habir. Welcome you again to this lecture series of tensors. In this lecture, I'm going to teach you about linear transformations. That means how we can transform a tensor linearly to another tensor or something like that. So in this lecture, lecture is all about a linear transformation. A linear transformation. So in this lecture, I'm going to teach you all about that. So how we can transformation? To transform a vector to another vector or tensor to another tensor, we need a transformer. So let T be a transformation. Say let T, okay, T be a transformation that transforms any vector into another vector. For example, if T transforms a vector A into C, say for example A into C and B into D. So this transformer that means this T transforms A into C and B into D. Then how we can write down that? Then we write T transformation of A equal to C. So T transforms A into C and T transforms B into D. Okay. Yeah. If so, we are interested here to discuss of the linear transformation. So if the transformation process is linear, then we say T is called the transformer T is called the linear transformation. So for example, uh, if the following if the T follows the following properties, then we say it is a transform. So if T is a transformer that transform two vectors A plus B, summation of two vectors A plus B in such a way that transformation of T plus transformation of B. That means if the transformation of T, if the transformation of A, if the transformation of B is equal to same as the transformation of A and B, or if T transforms A with a scalar vector A, say for example A is a vector and alpha is a scalar, then if we write say for example a scalar is put out and Ta in this way, then T is called the linear transformation, something like that. It is also called the second order tensor or simply a tensor. An alternative and equivalent definition of linear transformation can be given, say, in the following equation. Say, here T um, alpha A, sorry, alpha A plus beta B into this way. So alpha transformation of A plus beta transformation of B. Then T is also called linear transformation where alpha and beta are two arbitrary scalars and A and B two vectors, something like that. And I'm going to give an example how we can do that in linear transformation or something like that. So for example, here if we have two transformations, say for example, if we are given, so these examples are taken from the book Introduction to Quantum Mechanics and the example number 2.6.5. So here, if we have two vectors A and B, and T transforms A and B in such a way that say we are given T of A equal to A plus 2b, and then we have T transforms of B equal to A minus B, right? And we are given also another vector, say C equal to 2A plus B. Then we are asked to find transformation of C. So how we can do that? The transformation of C is nothing but transformation of C equal to, so transformation of 2A plus B, right? So we can write down here uh, T transformation of 2A plus transformation of B, right? So here we can write 2 transformation of A plus transformation of B. So we are given of the transformation of TA and transformation of TB, right? So what is that? 2 transformation of A is here a plus 2b, right? So a plus 2b and transformation of b, a minus b. So whole thing here is ca plus 3b. That means we can bring out t out of that, so we can write down a plus b. So transformation of C is 3a plus b. So this is the linear transformation, like a linear vector or linear matrix from the linear algebra. So it transforms these two vectors linearly into a new vector that follows the linear equations or linearity. That's why you call it is the linear transformation. I hope you enjoyed this class, and I will see you on next lecture, next video. Thank you.